Today's presentation is all on lithium batteries, getting you to understand a bit more about lithium batteries, what they do, some safety issues, different types of lithium batteries, all those types of things. So I'm going to get into it. I'm happy to take questions at the end. I've also bought a demonstration unit as well, which will give you some ideas about what's actually inside those batteries and a little bit inside what those inside those black boxes. All right. I can go back one. Okay, that's myself, David Bayliss, 12-volt guru with BMPro. I've been with BMPro since the inception of the brand. And my wife and I, Louise, we started this back at 15 years ago. Enjoy getting out there myself. I'm not a caravan, but I'm certainly a camper and out there with the kids and in the swags and everything else like that. My day-to-day rig is the Land Rover, which I get no end of ribbing from everybody out there in the bush saying how pathetic they are, and I do agree. Make sure you only own one whilst it's under warranty. However, my pet project on the side is the little Toyota Land Cruiser there to restore that one, which is what I used to do when I was about 18, 20 years old. All right, BMPro. BMPro's been around as a company for about 50 years, but as a brand for only about 10, 12 years. We've installed over 200,000, 250,000 plus now power management systems in caravans and RVs here in Australia and also now in the Americas. So we've been working in the United States for about the last 4 or 5 years now. So we've got a lot of engineers that sit behind us. I'm not an engineer. I'm not an electronic specialist. I'm not even an auto electrician. This is just all about my passion and what I've learned over the last 5, 10 years with lithium batteries. So we've got a big team of engineers back in the factory. So it's all designed and manufactured here in Melbourne. Out in Knoxfield, and all the gurus behind the scenes is what makes us have such a great product. Rightio, so getting into lithium batteries and why lithium iron phosphate, why are they now seeing as such a big replacement for lead acid batteries? Well, it's pretty simple. It's got a very similar voltage to a lead acid battery, so the advantage of that is you can basically drop it into the same space and use the same types of electronics as what you're normally used to being able to use, and it's what they call therefore a drop-in replacement. It also comes in the same sort of sizes. So you've got 2 different sizes of cases in a standard battery, and the lithium batteries have been designed to actually be able to fit normally inside directly into those cases. I'll show you a few examples though coming up where it actually hasn't and hasn't done well. It can be charged very similar to a normal lead acid battery. There are some intricacies which I'll go into. It's a safe form of lithium. So there is a lithium ion and then there's a lithium iron phosphate. Lithium ion contains a whole different range of other chemicals in there. Lithium iron phosphate is one of the safest batteries that you can get from a lithium ion constitution, and I'll show you exactly why in a minute. One of the main reasons though is because if there was an event, a thermal runaway event, so that thermal runaway is much higher than the other battery. So to have an issue, it's going to require a much higher temperature in which to actually have an issue. Very high cycle life, very cost effective. I'll show you those numbers in a second. And a slow capacity for loss, which means that when you put your caravan into winter storage mode, you'll be able to leave it in winter storage mode for quite a while and not have any worries about it. A lead acid battery you would generally be recharging once every 3 to 4 months to make sure it's trickle charged up and the battery is therefore maintained. But with a lithium ion battery, you don't need to worry about doing that. Okay, so as I mentioned before, there are a range of different lithium ion chemistries. So we've got cobalts in there, we've got manganeses in there, titaniums, and a whole range of others all mixed together. Is this my pointer? It is. Okay, so we can see here what they do is they stack them all up between lifespans, life cycles, safety, specific power, specific energy and cost. And your lithium iron phosphate, which is your purple one up here, you can see moves into this area here. So it's not it's one of the cheaper battery, not the cheapest. Its lifespan is good, its specific power is good, but from a safety angle here, it's one of the safest. It is the safest lithium-ion battery that you can actually buy in the market. So from time to time, different people will come out with different fancy chemistries. What can we do here? What can we do there? At the end of the day, a lithium iron phosphate, so LiFePO4, is your safest lithium battery which you can get out there in the space. Okay, so it's a really simple, the summary is it's actually a really simple numbers game. And I'll go through each of those in more detail in just a minute. So from a weight perspective, half the weight, standard for standard, half the weight of a standard lead acid battery, which are big bricks, 27, 28 kilos. Lifetimes, 10 times more cycles. you'll get a lot more cycles out of a lithium battery than you would ever get out of a lead acid battery. Energy, 60% more energy is available. A lead acid battery you would normally only charge down to around about a 50% depth of discharge. In this case, with a lithium battery, you can easily charge it down to 80 or 90% used and leave it at 10 or 20%, no problems whatsoever. Its capacity can discharge twice as fast. So the beauty of being able to do that now is with all the additional appliances that you're finding in your caravans. So it could be that you've got an inverter, or it could be that through that inverter you're running a induction hot plate or a microwave or a hairdryer. It gives you the ability to be able to pull out a lot of power really fast for short periods of time, whereas a lead acid is a lot more limited in what it can do there. You can charge it 5 times faster, so whilst you can get the energy out twice as fast, you can actually get energy in 5 times faster, which is great for you when you're out on the roads because it means that you can then recharge your battery faster and more efficiently than what you could with a lead acid battery. It'll take a lot longer. So lithium will charge for you a lot faster. And it's got a winter mode, as I mentioned actually at the beginning. I jumped ahead of myself. It's 6 months. So you can easily leave your van in storage for 6 months and you won't have any, as long as you leave your battery reasonably fully charged before you go into your winter mode, you'll then be able to just leave it all winter and not be worrying about it. Okay, so breaking these down a little bit more. A standard lithium battery that we normally do is around about 12 kilos. Most of the lithium batteries in the market are going to weigh between 12 to 14 kilos. Whereas a 105 deep cycle AGM battery full of lead on the inside is going to weigh anywhere between 25 to 28, 29 kilos. So there's a big reduction in weight by moving to a lithium battery. The advantage therefore, I mean, we know we've got limited capacities inside the vans, so by the time you fill them up with fuel and water and all the gear and all that stuff that we never really use, we can add a couple of extra batteries and it's not going to affect your load carrying capacity at all. Okay, so from a cycle testing perspective, so at BMPro we've got a tester back and we've had one of these Invicta lithium batteries ongoing for, I think this one started in 2017. We had it in operation for 9,500 days, and what we were doing was we were charging 20 amps in, 20 amps out continuously, maybe a 2 or 3 minute break in between. And what we were able to do is we were able to pull out 2,000 cycles, discharging it all the way down to 2% left. So we took out basically all the energy out of the battery. That equates to over roughly 5,500, 6,000 cycles if you're discharging it down to about a 10 or 20% capacity. So unlike a lead acid battery where you're likely to get, we've done similar comparisons, and you can get between 250 to 350 cycles out of a lead acid battery before its effective capacity is removed. This didn't stop, and when it did stop, it still stopped with a capacity of amp hours up there at 80 amp hours. Could have kept going if we wanted to, but we sort of figured we proved our point by having it going for 3 or 4 years there. All right, so greater cycle life. So what that means for you overall, what that means is that you can use the battery for longer. So a lead acid battery in a reasonably well-used environment in a caravan, going away 2 or 3 times a year, charging it up every now and then, you're probably going to get 4 to 5, maybe 6 years use of out of it, of lifetime out of it. Whereas with a lithium battery, you're going to be getting 10, 15 years out of it, no problems whatsoever. So your cycles, you get the much greater number of cycles on it. And as you can see, the lead acid, use the right one, the lead acid there. So the more you discharge it down on the lead acid, the number of cycles. So this one there, we got 300 cycles at 100% depth of discharge. 100% depth of discharge on a lead acid battery is only down to 50% remaining capacity. You wouldn't take it any further down than that. So basically what that means overall in summary is you can replace your AGM battery in your caravan 6 times before you would have to replace your first battery in a lithium style environment. So from a cost perspective, even when lithium batteries were up at $1,000, and they've come down a lot more now, even when lithium batteries were much more expensive, it was still more cost effective. As lithium batteries have continued to come down in price, it's becoming even more cost effective. Okay, so as I mentioned before, recommended depth of discharge. So on an AGM battery, so a lead acid battery, you'd be recommending that you'd be using it down to the last 25%. You'd probably stay away from this amber area here. This is when you'd normally have a look in your van, have a look at your monitor and say, oh, it's probably time to charge the battery now. This is the area where you want it. Now, on an AGM, the idea is you want to exercise it. So you want to go up and down, you want to be able to put the energy in and out, and that will maintain the life of it, but you ideally keep it around 50%. No, don't go any further than that. Lithium is different. It's very safe to, and it's very practical to, charge it right down here to 99%. So 1%, 2% capacity remaining. Most are probably going to recommend around about 5 or 10%, but there's no reason at all why you can't be charging it down even further to that 1 or 2%. As I mentioned to you before, the battery which we tested it at BMPro, we were testing it down to, I think it was about 2% remaining capacity, and we got thousands and thousands of cycles at it. So you can see your voltages. Some people prefer just to look at it from a voltage perspective as opposed to a depth of discharge perspective, which is a little bit more of a complicated concept. So here we can see here that when you're looking at a standard voltage, your voltages at 100%, on an AGM battery is around about 12.9, 13 volts. And once you start seeing on your monitor that's around 12, 12.2, that's when you start to realize that that's going to be getting down a little bit lower. On a lithium battery, however, the voltage holds up for a lot longer. The way the chemistry works and the way the internal mechanisms of the battery work, the voltage will hold up a lot longer. So what that means to you is that what you'll see is the voltage here remains in 13s and high 12s all the way, but then it drops off very quickly. So they're both flat at 10.5 volts. However, the lithium takes a lot longer to get there. Now, what does that mean to you as a caravan user? Well, over here, this is what it means. A little bit hard to see the pointer with blue into green into blue. But the usable capacity of an AGM battery sits in underneath that line there. Because the voltage stays up higher on a lithium battery, you can get much more use out of it. Now, for those who'd like to get a copy, see a couple of you taking photos, so if you'd like to get a copy of this later, we'll actually give you a QR code and you can scan it and download it from our website at no charge. So the reason that happens is because the voltage holds up higher. Now, the very simple maths of that is think of something that takes 1,000 watts to run. So it could be a motor, it could be a hairdryer, whatever it is. It takes 1,000 watts. Volts times amps equals watts. So simple maths is when you reduce the voltage, you have to increase the amperage to be able to take it back out on the other side. So volts times amps equals watts. So if the voltage comes down, you have to pull more amps out of the battery to make that appliance keep working. That's why a lithium battery, that's why a lead acid battery is not going to give you anywhere near as much effective capacity. Okay, so cost-wise. So deep cycle, if we just do the very simple numbers, and I had to modify this to reduce the price because the lithium batteries are certainly coming well down in price at the moment. At 100 amp hours, a 50% depth of discharge, which is what I recommended earlier on. Your cost on a good quality AGM is going to cost you around $300, and a good lithium iron phosphate, $800. I know you can get them cheaper, you can get them more expensive, but let's just sit at $800. On an AGM, if you discharge it down, you'll get maybe 650 uses. At lithium iron phosphate only going down 50%, you're going to get over 6,000. We got over 3,000 at 98% capacity, so you'll get well over. That's why they can say you can sometimes get up to 8 or 10,000 cycles out of it. So your return on your investment, you're going to have to replace that, and according to those maths, you'll have to replace that AGM battery 9 times. So I gave you a rough example before of 6. Here's the mathematics on it, and compensating it back down the other way for being conservative. You're going to replace it 9 times. So your cost then per kilowatt, a little bit more complicated. Again, download this later and study it if you want. There's no test at the end, so you'll be okay. The AGM is going to come in at around 70 cents per kilowatt hour, whereas the lithium iron phosphate is now going to come in at around 23 cents per kilowatt hour. So it's coming in a lot cheaper. So especially if you're starting to do, you're doing a little bit of off-grid camping, you want to get away for a few more days and things like that, having a lithium battery there in the longer term is going to save you a lot of money. Okay, so price versus quality. It's a really difficult one because even like a lead acid battery, it's a sealed black box, except for the sample I brought along here today. But you can't see inside the voodoo. So all the chemical reactions that are going on inside, you can't see anything of what's happening inside there. So type of construction is really important. Making sure that it's in a really rigid case. Making sure that you're buying it from a reputable supplier. You'll find Cheap and Cheerful on eBay. We find it all the time on Cheap and Cheerful eBay. You can buy good quality from eBay and China. You can buy poor quality. So trying to stick with a reliable brand is going to offer you a better chance of buying a better battery. The BMS. So inside these batteries, which I'll break into it in a minute, is in the construction, there's a set of electronics that sits over the top. It's called a battery management system, the BMS. That is what controls the power and the energy that goes in and out of the battery to all of the individual cells that are in there. So the quality of the BMS is something which is really critical to ensuring that you're going to get longevity out of your battery and you're going to get reliability. The other big one is certification. Anyone who won't give you a copy or show you a photograph or whatever it may be of the certification of their battery, it's probably because they don't have it, it's probably never been properly validated, and it could well have gone through a very dodgy Chinese laboratory. Just because it has got a stamp on it doesn't actually mean that it's a quality product. We've seen testing laboratories overseas where they've been testing a product and they've wrapped massive toroids around the output cables to soak up all the electromagnetic interference that you get. The old days of when the washing machine would interfere with the television, that's what that is. And they were testing it with these temporary toroids on there, and they were giving it a tick and then just flicking it out the door and taking the money. So that's why I would suggest pay the money, stick with a reliable brand, and make sure you can have a look at the certifications. So for example, of every battery which we sell through BMPro, you should be able to find the certifications up there on our website. And the other brands out there, they're doing exactly the same. So the other well-known reputable brands that have been around for a long time will be able to offer you exactly the same. Okay, so compatibility, making sure, there are some stories out there that people say that you don't need to have a lithium-ion charger. That's BS. So a lead-acid charger may, depending upon the battery, may be able to charge your lithium battery all the way to the top, but because it operates at much higher voltage, it's going to take a long, long time to get there. And when you're trying to recharge a battery moving between locations, that's going to be almost impossible. So the best thing there is to make sure that you find a charger that has definitely got a lithium-ion capacity. Most chargers you'll find out there can do lithium-ion and can do sealed lead-acid. All right, I've just basically spoken all about that. You can get that off the website. The other big reason why you want to have a dedicated charger that's got a dedicated profile, and this is a really important one, is that inside the lead-acid battery, as I mentioned before, it's got electronics, the battery management system. In there, there's high-quality, top-end processors, microprocessors, and semiconductors. In the battery chargers, there's the same. If those two are competing against each other, in a lead-acid profile, you'll have things like pulsing modes and trickle charges and things like that, where it goes on, switches, and does that. Well, over here, the BMS is not going to like that. So they're going to start competing against each other. So you may not, and we've seen many cases where one charger, a lead-acid charger, will not work with a lithium battery. And people have said, but I can only get it half charged. Well, the reason being is that the BMS inside that battery is shutting down because it's getting conflicting signals from the lead-acid charger. So make sure that whatever charger you're going to use for your lithium batteries has got a lithium-ion profile in it. It's a 3-stage charging curve, whereas most lead-acids are normally using a 5, 7, or 9-stage charging curve. Don't waste your money by not getting the right charger for it. Okay, so why does it charge faster? They have a lower internal resistance inside them compared to a lead-acid battery. And as a result, that means they can accept a higher charging current, and they can accept it for a longer period of time because of that less amount of resistance. So it also has a higher charge acceptance rate. So what it basically means is on a lead-acid charger, it slows down as it fills up, whereas a lithium-ion battery, you can just thump it, get the energy in there, and then it'll just finish off on the last bit, and as a result, it'll accept that energy in there a lot faster. Same again as I was mentioning before on the discharge rate. You can discharge it faster, you can charge it faster. It doesn't have an absorption phase. So again, this is coming back to before where I was talking about the different stages of charging. Make sure that you've got the right charger because it doesn't have an absorption phase. And it's got a higher efficiency. Lithium batteries are typically around 95 to 98% efficient. So whereas with a lead-acid battery, you try and charge it faster, you're going to get more heat build-up. What is heat? Heat is energy, and that's inefficiency. So that's coming out of the battery. That's heat that's being lost. It's energy that's being lost. No sulfation issues. So lead-acid batteries suffer from a sulfation when they're not regularly charged. So therefore, if you've had a battery that's sitting around and the plates have been building up and they've sulfated on the inside there, you're not going to be able to get the charge back into the battery the way you'd be able to normally if it was a brand new battery. Lithium doesn't suffer from that, doesn't have that same issue. And you've got an advanced management battery system. You can have a look at the one that I've got down the front here. It's not going to tell you much, a fancy green board, but effectively what it does, there's individual cells inside that battery, and as a result, it charges each one of those or allows the charge to each of those to be optimized depending upon temperature, etc. So if the temperature on one of the cells in that battery, and there's multiple cells, if the temperature in one of those cells was getting too hot, it would then slow that one down to allow it to cool or similar, and then it would just keep charging the other ones. Okay, features and benefits, we spoke about that. A deep cycle AGM battery, it'll drop down to 12 volts very, very quickly. So that was where I was showing you before. The voltage on a lithium battery will hold up for longer. As a result, it'll draw less amps than what you need if you've got a lower voltage. If you've got a lower voltage to power a device, you're going to need to increase the amperage, and it's going to therefore draw it down. So you can see there on the discharge time, and the harder you discharge them. So here on a lead acid battery, the harder you discharge that, the more quicker you're going to be discharged the actual battery. Whereas over here, it's going to take you longer to be able to do, and we can see well over here on the lithium batteries how that's holding up for longer. The disadvantage with that on a lithium battery is that when you see it at something like a 12.8, it could mean that it's going to drop off the edge very, very quickly. But you've probably well used all of the energy, the available energy, which is in there already anyway. Again, just reinforcing, recommended on the lead acid batteries not going below that 50%, whereas on a lithium battery, you can take it down to that 80%. Means you've got that additional power. So in the same space, so from an efficiency of space and available energy in there, you've got a much higher ability to store more energy in there. Low self-discharge, so this is where I was saying before, an AGM is going to discharge down to about 80% after about 4 months. The lithium iron phosphate from a full charge is going to take around about 6-8 months in which to be able to discharge even down to 80% remaining capacity. This is another one. This is Poucau's law, which talks about, from a physics perspective, it talks about when you take energy out of a battery faster, you'll have less remaining capacity. So in a lead acid battery, if you take out at 5C, so C is the capacity, if you take out, say, 500 amps in a very quick, short time, well, let's just do 1C. Let's take out the full capacity, because a lot of lithium batteries advertise you can take 100 amps out very quickly, and you can use that available capacity. When you take out 1C on that, it's only going to last you approximately 30% of the actual lead acid battery, whereas over here, these batteries are designed to be thumped in, thumped out, and as a result, you're still going to be able to get that, pretty much that full capacity is still sitting over here, in the high 90s. So even if you want to discharge it at full capacity, so at 100 amps at a time, you're still going to get the full charge capacity out of it. Whereas on a lead acid battery, it's going to diminish very quickly. So if you started pulling out 100 amp hours out of a battery like that, you're probably going to see the capacity of the battery disappear in about 30 or 40%, 3 times faster than what you would normally see on a lithium battery. The remaining capacity, basically you're going to flatten the battery a lot faster. So that's why you'd never use induction stoves, microwaves, hair dryers. You can use inverters, but you'd be wanting to have a large lead acid battery bank. If you're going to use a 2,000 or 3,000 kilowatt inverter, you'd want to have at least 200 or 300 amp hours of lead acid batteries in which to do that. But the faster you take it out, the less you're going to have left in there. Okay, that's just a little bit of reading after hours for you when you download it. Just the reason mainly because why Poucau's law works here is because of the fact it's got a higher energy density and again that lower internal resistance. Okay, so I mentioned at the beginning it is a really tough game because what's inside the box, whether it's a lead acid battery or a lithium battery, we don't really know. It's really hard to see and we don't get a lot of information. So a lot of people have had a lead acid battery over time and then all of a sudden it's died and they've got nothing remaining inside it. Nothing anybody can do. You can't tell what's going on, what's gone wrong. It could be a cell which has vibrated loose, piece of the lead. Could be sulfation. It could be any number of reasons. Until somebody, if they were to cut the top off the battery, then they might be able to tell. But that I don't recommend. All right. So inside there, you're going to have 3 different types of lithium cells. There are 3 different types of lithium cells in the market, and they all offer different advantages and disadvantages. You have cylindrical cells, which just think of that as the AA batteries. They have larger versions of those. These were originally used in electric motor vehicles. So BMWs, Mercedes, I'm not sure if Tesla did, but they used to have these big alloy cases that would sit underneath the floor of the car, and it would be full of around 2,000 or 3,000 of these F-size cells. Each individual cell is fused. Each individual cell has a temperature recorded against it, and it's a very complex beast that sits underneath it. That worked for them in which to be able to do that. Then you've got pouch cells. Pouch cells you'll find, they're the flat ones. Them you'll find in the back of, say, a phone, back of a laptop, A lot of technology where it requires a flat process. We have seen them in here. The challenge, though, in putting them inside a lead acid inside the lithium batteries, is that people don't generally monitor the temperature on each of them. I cut open a dead 12-volt lithium battery that had pouch cells inside it after about 18 months. And because it still had unspent energy on the inside, after I got the Dremel very, very safely around the top and lifted it off, the battery pack just kept expanding. And that was after 18 months. So in this type of scenario, it's definitely not recommended. The best types of cells to go inside a lithium battery are the prismatic cells. Prismatic cells are all individually certified, and as a result, you can then series them up or parallel them up, depending upon what voltage they are, and get the right number in the case. It also works very well as a drop-in replacement. The reason the lithium batteries have been successful is it drops into the same space, same size, and normally the prismatic cells on the inside match the internal mechanisms of those boxes, and so therefore it works very well, giving you your 12 volts. The most critical thing which is in there, though, is the BMS. So the battery management system, making sure it is well made, good construction, things like that, from a reputable supplier. Hard to tell, but it's that's going to be what breaks down. So you're not likely to find a cell breaking down inside there. You're going to find the battery management system will break down inside there. When that breaks down, that's when you've got a challenge. Okay, this is what we don't want to see, what shouldn't be inside and what we've seen inside when we've cut open batteries. We've even found roofing tiles inside batteries. Absolutely terrible. You don't want to see tape. So this battery on the left-hand side was one we cut open at our workshop. You don't want to see tape. You don't want to see goop. You don't want to see wires running all around it, which are the temperature sensors, and just pull off. We've got packing tape here. We've got electrical tape running over the top. We've got goop here. And this thing here, wonderful. So you've got a heat sink on the side here. And see the fin design of that heat sink? A heat sink is designed to remove heat away from whatever you want to remove it for. Where it could be in electronics, it could be in a car, it could be whatever it may be. Well, these clever buggers have put a piece of foam over the outside of it. That's pretty clever. Right, so that dropped inside the same box, inside the same size box that we've got here. This one over here, this is a publicly available photograph. It was up on the internet. Our guys with the orange lids, they decide to open the top of each one of those, even though every one of those units is certified. Each one of those lids is then opened and they goop it up to be able to hold it all together on the inside. Not what we're really looking for if we're doing the canning stock route or the back of the country. So again, sticky tape here, heat over heat sinks. This is just a joke. In here, they've even put insulation boards in here for electrical safety. We've covered it all up here with goop, and we've got foam to pack it out. So the reason I say that this is a poor design, the battery may go well. The BMS may go well. In fact, we've tested one of these and it performs fine. But the problem with it is that when you're in a caravan and you're on rough roads, and Australian roads aren't always the best, when you're on rough roads or you're going bush and you want longevity, you want the power supply to last. Best way to make a power supply last is to keep it cool. Don't block up the heat supply. You're going on a road that's got lots of vibration. Don't try and goop it up with Sikaflex. Don't try and hold it together with sticky tape and packing tape. If you're going to get a battery, get one from a reputable supplier with certification so you don't end up with this, because you can't see inside the box. That's why it's important. If the price is too good to be true, it is too good to be true. I go on about this because I hate it from a safety perspective. It's just wrong. No temperature sensor in that one. Beautiful. So we've got 8 batteries in there with no temperature sensing. You're supposed to temp sense every cell in there to meet the standards of the BMS. There's not one temperature sensor there. This battery was opened on the desk in front of the Australian Battery Standards Society. They just freaked out. So again, it's a poor quality design. Any product, whether it be a BMS, whether it be a battery, whatever it may be, if you start seeing goop on the inside and Sikaflex holding it together, it means that the design construction of those electronics you've purchased or seen are very poor. You should not need to do it. You'll see the one down here. There's proper ways to do it with bus bars, connectors, copper, and proper screws and bolts and everything else like that. So you see goop on any product, there's a flaw with the design. Okay, so our batteries that we bring out from outside, and I know a couple of our competitors do it as well, and I applaud them for sticking with the standards. There's a new standard out there called AS 3001-2008 that came out about 18 months ago, and it clearly states in there that your batteries should be certified and compliant to what's called IEC, which is an international standard, 62619. What does that mean for you as a consumer? That means that you can have comfort that the battery has been tested as a complete unit. If it's not tested as a complete unit and just tested as an individual cell, then you risk the fact that it's not going to work properly. The BMS is the most important part of it, so it needs to be tested with the BMS installed in it. What does the BMS do? It'll help you out with all of those things such as short circuit, impact, thermal abuse, overcharge, over-discharge, short circuits on battery cells, all those types of things. And temperature being the best one, the most important one. Temperature is the enemy of all electronics. So the hotter something gets, the less amount it'll last. Least amount it'll last. Terrible English. Manufacturing process, making sure that the assembly process, we probably won't get into seeing those. All right. So again, yes, as I mentioned, the certification. So 62619, it's really to ensure that when it's going into a safety critical spot, which in many cases is a telecom, a UPS environment, electrical energy systems, solar systems and things like that, you want to ensure that the battery is properly certified and has been therefore gone through a correct manufacturing process. Okay, one of the questions I get quite often in some of the columns that I write for is asking about these lithium batteries now being on the outside of the caravan. Well, some people argue that why are they put outside there? It's because they're so dangerous. Bullshit. They're being put outside there because no one can really interpret the standard as to how you're supposed to ventilate a battery on the inside of a caravan. So as a result, the caravan manufacturers decided the easiest way to figure this out was to put them all on the outside of the caravan. So you'll find most lithium batteries now are installed on the outside of the caravan, basically because it was not really possible to meet the standard with some sort of sealed enclosure vented to the outside, but shouldn't be vented on the inside of a caravan. So they decided, easiest thing, put a metal box on the outside, bang, done, we've solved the problem, we've met the regulations. So that's why you'll see them out there. So what rating should you look for? Some people have said to me, the battery needs to be IP67. Well, I guess again, I'm going to call bullshit. Because IP67, you want to submerge the battery, I wouldn't be worried about the battery, I'd be worried about the rest of your caravan. If you're going underwater, the battery's the least of your worries, so you don't need to worry about that. IP67, it means ingress protection. 6 is for dust, 7 is for moisture. 7 means that it can be submerged to 1 metre of depth of water for 30 minutes and not interfere with the general operation of the battery. That's the highest level you can get in this type of environment. You can go fully waterproof to a 68, but we're obviously not submersing things down to 1 or 2 atmospheres under the ocean. So an IP67 means that yes, you can do very deep water crossings and you can sit there basically and have lunch in the middle of the river for half an hour and your battery can be underwater. Again, really. So IP64, as long as your battery is IP64, 54 or an IP65, you're going to be totally fine. One thing to steer away from though, you'll see some people coming out with LED displays and indicators on the top of their batteries. My recommendation is don't go there. The rest of the battery is waterproof, but that's not. LED displays can't be waterproof. They don't have gaskets around the outside of them. So as a result, you'll get water inside that LED display and you'll lose your LED display on top. There's a couple of batteries around, including one of ours that's got a button on the top of it, but it's got a sealed rubber gasket on the inside of it, which is designed for it, and it's therefore rated IP67. So you don't need 67. It's a high-pressure hose. IP54, splashing in low creeks. 65, that's great. It's glue sealed around the top there. Doesn't have a gasket. You don't really need a gasket around the outside of it, but it's not just a screwed down lid. The problem with an IP54 is lots of people shove pressure hoses on their caravans, get in underneath there and try and clean it up after they've gone away on their adventure and covered it in mud. And as a result, you could get some sort of water on the inside. Is it likely to cause damage? No, but it's not optimal. So IP65 is our recommendation. Yeah, it's IP67, but the caravan, neither of the car is IP67 neither. I'm not sure where they were, but a couple of photos I found off YouTube. Okay, so in summary, and then I'll throw it open to questions so you can welcome to come up and have a look at the battery. Buy from reputable brands that have longevity in the market. There's always newcomers coming into the market, but honestly, I would go with people who have been in the industry for a long, long time. There are companies out there who have been out there longer than we have, and by all means, they certainly sell good quality batteries, as do we and a couple of the other ones. So, as I mentioned before, and my mother always taught me, if the price is too good to be true, it is probably too good to be true. There's a reason it's cheap. It's missed out on certification. It's missed out on good quality componentry on the inside. People haven't checked the battery management system. A whole range of different reasons. So I know lithium battery prices are coming down, but working on paying a reasonable price and buying from a quality, reputable supplier, you should not come unstuck. So again, price will normally equal value and safety. A battery that needs to be discounted to be sold, well, it's not holding up to its own value proposition in my opinion. You know, it should be a battery sells on its quality and it sells on the company that's selling it, not because of the fact that you're offering a $500 discount. So if someone's offering lithium batteries reduced from $1,000 down to $500, you know, they're having to get rid of product and that's not selling actually on its quality in my opinion. And the last one I had was asked to see certifications. And it should say on that certification there, battery tested, not cell tested. The battery has been tested to the appropriate standards. Very quickly, a couple more slides. Thermal runaway. You may see some of these fires that happen. So to put that in perspective for you, what it is effectively is the battery keeps charging. So the one that happened recently, there was, or the one that they know the result of, Eastern Golf Course in Croydon area. In Victoria, there was a golf cart, correct? So I've got electric scooters at home, but I set my electric scooters only to charge between 5 p.m. and 7 p.m. when the family's home. So if there's a problem, someone's here to turn the PowerPoint off. The problem they've had with golf carts, for example, is that they just stay plugged in all overnight. And if there's a poor quality BMS inside there, it'll just keep sucking the charge. So as the resistance goes, the charge just keeps coming in. You get a thermal runaway event where you get so much heat that it ends up cooking and then it'll start a fire. The fire brigade in most cases cannot put these out. They are too big. So you might see houses up in Brisbane that have gone from electric scooters. Hoverboards was one that went in the Northern Territory. The house has to burn to the ground, unfortunately. You really can't stop it. In a small enclosed environment, there are the chemical fire extinguishers, which you can do. So you can't starve a lithium fire of oxygen. That doesn't work for it. You won't be able to starve it of heat because it'll generate more heat, generates its own heat and just keeps going. The chemical fires, what they do is they spray the chemical on there to stop the surface area of the fire, and so therefore it runs out of fuel. So, but you need a lot of it in which to be able to stop a large fire. And the fire brigade won't go pumping, 20 kilos of chemicals onto a house fire to try and stop it. So you can do it with specialist chemicals. That's why they say on the airplanes these days when you fly, if you drop your phone down beside the seat, they say, please don't move your chair and get it. Ask the hostess to reach down and grab it for you. Because you go moving your chair and you jam it in the electronics there, you potentially can cause a fire with the impact on it. So that's what thermal runaway is. But if you've got lithium iron phosphate, it's the safest possible chemistry that you're going to have. It takes a lot longer for that temperature to get up there, and it's a lot harder to get to that temperature, and then therefore to be able to cause a fire. Second summary. I already had one. I'm going to get my slides right. Less than half of weight of lead acid, flat discharge curves, greater number of cycles, reduced charge times, longer shelf life, greater use. Nothing wrong with lithium batteries. Buy good quality lithium batteries and you won't have a problem. There you go. Thanks very much, everybody. Thanks for your time this morning. Happy if you want to come up and ask some questions. So yeah, happy to take questions from the floor as well.
Oh, that's a big and. For the Victorian Caravan and Camping Supershow, the biggest and best and the most exhibitors and the Adventure Zone and the Kids Zone and the RV Master Stage and lots more. And only $20. Melbourne Showgrounds, February 19 to 23. Tickets at caravanshow.com.au.